Hello and welcome to a flipped classroom presentation on Newton's third law. And in this presentation, we will learn to find equal and opposite forces. If you remember, Newton's third law tells us that for every force, there must exist an equal and opposite force. Now that equal and opposite force will act on some other object, but be the same kind of force. So it helps if we know where these forces actually are. So let's do a few examples. We'll start with something simple. Let's suppose someone is getting pushed. This person in the black shirt is getting shoved, and there is a force acting on him in that direction right there. Now, if there's a force pushing this person that way, there must be an equal and opposite force, i.e., there must be a force which is pointing in the other direction. Now, what could that thing be acting on? And here we're going to use a general principle. Anytime there's a force on something, like the person in the black shirt, that force comes from the fact that there are two things that are interacting. And that the equal and opposite force is always on the other thing that's interacting. So what two objects are interacting? Well, in this case, it's the two people, the person in the blue shirt and the person in the black shirt. So since they are interacting via force, the black shirt person gets a force in this direction, so there must be an equal and opposite force on the person with the blue shirt. Right? So this is generally how we proceed. We figure out what two objects are interacting to create the force, and the equal and opposite force is always on the other object. So let's do another example. Suppose there's a mass that's hanging by a string. So here's the mass, here's the string, and it's attached to the ceiling right up here. Now, we know that there is a tension force acting on the mass, which is pulling it straight up. Where's the equal and opposite force, and what is it acting on? Well, what does this little mass interact with that's causing this force? The ceiling. So that means that since it's interacting with the ceiling, the equal and opposite force must be pointing, of course, in the direction, and it's acting on the ceiling. The ceiling pulls the mass up, and the mass pulls the ceiling down. Right. Now for the next one. Suppose somebody is walking on a floating log, and this person pushes off the log, and a friction force then pushes her in that direction, right there, to the right. There must be an equal and opposite force. Well, what is she pushing off of? What is she interacting with to get this force? There's a friction force between her feet and the log, so the equal and opposite force must be acting on the log itself. So there must be a friction force which pushes the log in this direction, right there. Now you might have experienced this before if you've ever been on a boat or in a similar situation where you have tried moving on a boat, and you might have noticed that the boat moves in the other direction. So you can see this happening. What I find quite interesting is that this principle works if you're walking on the ground as well. So let's suppose you're just walking on the pavement, on your sidewalk, and there is a friction force which pushes you forward. You are interacting with that sidewalk, which is firmly attached to planet Earth, so the equal and opposite force pushes the entire planet backwards just a little bit. Now, it is a very little bit because the Earth has such a tremendous mass that it hardly accelerates at all, whereas you have a relatively small mass, so you accelerate quite appreciably. Now, time to blow your mind. In our next example, we have a child who is bouncing on a trampoline. She is in midair, and while she's in midair, there is only one force acting on her, which is the force of gravity. and that force of gravity will pull her downwards. We're going to ignore air friction because air friction is pretty small and not all that important. So, where's the equal and opposite force, and what is it acting on? Take a moment to think about this. Pause the video if you like. All right. So, what object is pulling her downwards? What's causing that force of gravity? It must be planet Earth. So, she is interacting with Earth. That means that the two are exchanging forces. If the Earth is pulling her down, she must be pulling the Earth up. So our equal and opposite force will act on planet Earth, and it will pull the entire planet up to meet her. And why doesn't the whole Earth start vibrating like crazy? Again, it's because the Earth has such a huge mass that little force hardly affects it at all, whereas a person does not have nearly the mass of the Earth, so that same force moves that person quite a bit. Now, I'll let you put it all together here. There are 4 forces acting on this person who is leaning against a wall. Each of those forces has an equal and opposite. So I'd like you to draw the free body diagram of all the forces acting on the person, and then identify all the equal and opposite forces and what kind of forces they are and what they are acting on. And go ahead and grab a piece of paper and do that. Pause the video and I will wait. Okay, let's do it. First force, the wall is going to push her to the right. That's a normal force. Next up, there is another normal force, which is going to push her upwards, keeping her from sinking into the ground. Force of gravity pulls her downwards. And the fourth one can be a bit tricky. Imagine if she were wearing a roller skate, her leg would zip out and she would fall to the ground. So she needs some friction to hold her into place, and that friction force will point in this direction. So those are the 4 forces that are acting on her. Now, so far, we've only drawn the free body diagram for her, and those are just the forces that act on her. Each of these forces must have an equal and opposite. So let's go through. The normal force pushing her to the right. What is she interacting with that can generate this force to the right? The wall. So she must be pushing the wall backwards, or trying to. And if you think, gosh, if that wall were like made of paper or something really weak, indeed, she would push herself right through the wall. She has another normal force. The ground is pushing her up. She's interacting with the ground, so she is pushing the ground downwards. Gravity is pulling her down. She's interacting with the Earth and pulling the Earth upwards. Finally, there is a friction force pushing her into the wall, but she's pushing the Earth this way to the right, away from her. And those are all the equal and opposite forces. Now, I want to talk about how rockets work in space, because it's all about Newton's third law. And I want to start by talking about bowling. Because, yeah, bowling and rocketry, they're basically the same thing, right? Well, in a sense, yes. So I have a picture of somebody who is bowling right here, and I'd like you to imagine that she is bowling on frictionless ice. She applies a force to the bowling ball, pushing it down the alley. Where is the equal and opposite force? Well, she's interacting with the bowling ball, so it's going to push her in the opposite direction, away from the alley, i.e. backwards. So if she were on frictionless ice, she would bowl the ball, it would go down the alley, and she would go backwards a little bit because she'd be pushed backwards. Well, in space, when rockets are used, there is nothing for a rocket to push off of. So how can a rocket possibly move? And it uses the same principle as a person who's bowling on frictionless ice. The rocket sends some gas out the back at a nice high speed, kind of like bowling a bowling ball. Boom, the gas is flying out this way. So the gas is pushed backwards, and by Newton's third law, that pushes the spacecraft forwards in this direction over here. And voila, that's how rockets can operate in deep space. Okay, just to sum up, what you've learned is that for every force, there is an equal and opposite force. It is the same kind of force, and it acts on a different object. In order to find what that force is acting on, you figure out what is causing the force, what two things are interacting, and those two things are experiencing the equal and opposite force. Okay. Have a good day.